Uh, the sailboat here, has to pull a load. This load has a mass which is much greater than the mass of the sailboat. In pink, here you can see the trajectory of the load. Between the boat and the load, you have a cable, which has to maintain straight to avoid loops. This arrow here shows the direction of the wind. So if you want, the robot at this moment is going upwind. The load here has to follow a circle, which is represented here. It is a huge circle. In red, you can see the wanted direction for the load. But you can see two arrows. One corresponds to the wanted direction and the other one to the feasible direction. This one is a feasible direction and the wanted direction. So I will now explain this, what is a feasible direction and a wanted direction. So, due to the wind, there is some directions that are not feasible. I will define first the notion of segment. A segment, as you can see on the video, the sailboat is going and come back, go, come back. And here you have some kind of transitory motion. So at this moment, what is a segment? A segment is an arc where the robot goes in a direct and an indirect sense. Some arcs are unfeasible. For instance, this one I show with the mouse does not correspond to a feasible segment. Why? Because the robot is able to follow this segment downwind, but not upwind. It will have to maneuver. What is a wanted direction? To follow the circle, the load has to be pulled with respect to a direction. So in fact, when it is here on the left, I will pull on the right. And when it is on the right, I will pull on the left. When I am on the circle, then I will pull with respect to a direction corresponding to the direction of the circle. So this is the wanted direction, and I project it with respect to feasible direction, pull direction. And the feasible pull direction are here and here. So I project the wanted direction with respect to a set composed by upwind segment and downwind segment. If I continue applying this strategy, then the robot will perform several circles as explained in the paper submitted at the WRSC. Thank you for attention.